All right, guys.
You gotta get this washed before next Saturday, dude.
So I'm testing something just because, like I said, I know we have one student who's kind of doing home instruction and other classes. There's obviously a lot of people going on quarantine or whatever. So I'm going to try to record this class and see if I can tweak this to where these videos will actually do you guys some good if you miss class. Anyway, for today, we're going to continue that G and M code presentation. Technically speaking, this is all the different presentations that we might cover. But this one right here, I'm not sure if it will because it just utilizes a specific software that you would only be able to use here in our Butler Tech computers. It's nice because it simulates an actual CNC machine, but I'm not sure it will be very beneficial for what we're doing. So I don't know if I'm going to go over that 40-something page slides presentation. So let's get to where we left off yesterday, and I'll just go through it very briefly just because since I'm doing this in a video now, I'd rather see if everything goes as I want. So as you guys can see here, right, this is what we talked about. We were talking about G and M codes yesterday. So what were G and M codes? Again, they just were used to operate CNC machines. CNC stands for computer numeric control. They began with that punch tape on the right side, but obviously as computers became more powerful, smaller, and more easily and readily available, they were then developed into computer chips, and that's how those computers now run those CNC machines to produce those parts in the manufacturing industry. As for today, this picture shows you, right, the CNC machine. We have a very basic 3-axis CNC in the back room. We have 2 of them, but one of them is currently down because of the limit switch issue. But with that being said, this CNC machine will have a lot more protective guards. It'll be able to use, a machine metal. We're usually going to be machining something that basically turns the material to dust. We shouldn't have to worry about chips flying at us or anything like that. But this machine has more axes. So you guys have obviously heard of the X direction, the Y direction, the Z direction, whether it be from modeling or whether it be from math, right? The same concept applies here when you are doing your coding. A lot of times you will have an X-axis, which is going to move your tool left to right. You'll have a Y-axis, which moves it forward and back. And then you'll have a Z-axis, which goes up and down. So if I'm looking at, if I'm looking at this particular machine here, well, this right here is called the spindle. And this is where you would put your tool. So this spindle here, which is where my arrow is, usually this is your X or your Z direction, excuse me. So this would be, going up would be positive Z, going down would be a negative Z, okay? So then when you look into the machine, your X direction would be this direction, left to right. So that would be your negative X, this would be your positive X. And then obviously your Y direction then would be going in and out. So it'd be kind of, if I drew it kind of 3D, it'd be like this. So your positive Y would be going that way, and your negative Y would be going this way. So those are going to be the different directions that you can tell your machine to move, or that you can tell your machine to program and machine something. But like I said, basically G and M code is going to translate human language, so what we want it to do, into machine language, so that the way the machine knows exactly what we're trying to accomplish. It's going to be typed into a computer nowadays or generated by a program. Our class will probably do a little bit of handwriting our program, and that's called manual programming. But it's not as bad as it sounds. All right, so I should be on the back of my mouse now. Cool. So we talked about these sample block programs. So this first sample, we talked about how N02, that first line there, is called a line number. And I think I technically skipped one. Okay. So N01 is called a block sequence or line number. Okay. The reason why you guys have those N numbers at the beginning of your code is so that way if you ever need to stop a machine with an emergency stop, like we talked about previously when you guys made your conveyor systems, we've been talking about emergency stops. If you ever have an emergency stop situation and you don't have what they call an auto recovery program, this will let you know where you stopped your program within your part. Now, whether or not you can salvage that part, depending on why you stopped the machine, is obviously a different case. but it's always good to know where you stopped so you can figure out and troubleshoot what the issue might have been. The M06 right there, which I guess if I'm gonna use this video, I'll just start using my pointer here. So that M06 there, right? That is what they call a miscellaneous code. That's what the M stands for in M codes. So M06 is a tool change. I mentioned to you guys yesterday. With our particular machines, we are going to manually tool change everything. We're going to take our hands, put in the proper tool that we want to put in there, and tighten it down. But in that machine that was shown in the previous slide, there's what they call an automatic tool changer. So that way you can have preloaded tools already there, and then the arm comes out, takes the tool out of the spindle, and puts a new one back in for you. And then T1 is just going to be the call out for what tool you want to bring in. So if you were going to bring in tool 35, obviously that'd be T35. You try to make it to that way. Everything makes a lot of sense. It's just straightforward, and you're not going to say T35 is actually the first tool in my sequence. Usually you want to keep it in numerical order. And then after that, there's a semicolon to tell it you're done with your actual code. And anything that you put in there is your comment. So again, depending on the situation, sometimes comments are going to be in parentheses. But in this case, they tell us that it's going to be just anything that you type in after your semicolon. It will not read as code. So here's another simple block of programming. So this time we have N02, right? And this is as if you were writing the code. This is kind of going line by line. So that's why the first line that we talked about was N01. And then this would be the next line of code. So you have your tool called into your spindle or into your machine. And now what you want to do, well, you want to start that tool to let it start rotating. So line 2 would have a M code or a miscellaneous code called M03. That M03 tells it to rotate the spindle or turn on the spindle. And then the S call out right afterwards is going to be how fast do you want your spindle to rotate? So you guys are calculating that N value or that RPM number, right? So that's what this number would be. That would be telling it how fast do you want to rotate your spindle or your tool in revolutions per minute. And then this is when it gets a little more complex. So this is actually line number 3, right? So this would be the third line in a code. And this third line, it has a lot more call outs. You'll see these G codes now. This is the first time that we see G code. So the first line number here is G90. What G90 means is that you are setting your machine to absolute coordinates. The easiest way to explain absolute coordinates and incremental is going to be if we drew a Cartesian plan here, right? So we have the y-axis here, and we have the x-axis here. And this is our 0 point. So we're only going to talk in x and y just to make it easier. Let's say we wanted to move here to here to here, something like that. So that's our endpoint right here. And we could say this is 4, just to make it easy. All right. So for absolute, you could literally say, I want to move to this point to that point. All right. So everything when it comes to absolute is going to be back to your origin. It's going to be back to 0, when you type your numbers in. So 0, to 4 would be what you can type in, and it will move to that position 4 inches in the x direction, 4 inches in the y direction. But if we wanted to do something incrementally, it means that you could say, I want to move x1, or actually we'll go 2, and y0. So that would be this point. And then incrementally, if we want to move to this point next, that'd be y2, x0. So you'll see that it's not based on the position, but rather it's based on where you were from. So point 1 to 2 here, 0 to, I guess I'll put an X here just so you can see it. But from here at our origin to here, we'd move 2 over to the X, 2 inches over to the X, and that's it. And then from here up to here, so this point 2 here, we would move up 2 inches, right? So that's why it'd just be y2, x0. And from here to here at point 3, we moved over again 2 inches, or sorry, it should be 4 inches, I guess. So y4, x0. And then at point 3, we move another 2 inches to the right and 0 inches in the up and down direction. So incremental, guys, just think of it like moving step by step. It's actually asking how far do you want to move every time. But absolute coordinates, you're going to actually just type in what these numbers are. So 2, 0 is fine. That'd be the case. But for absolute, let me change the color here. And I'll draw it over here. So we're going here, 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 right? So for absolute, you would actually just type in what the coordinates are. So 2, 0, right? Because that is going to be 2 over the x. Up here, you would actually be typing 2 and then 4. And over here, it'd be 4, 4. Oops. 0 does not help there. That's unfortunate. So over here would have been 4, 4. 2, 4. 2, 0. And then 0, 0. All right. So again, at each of those points, we would actually just say, what is that point relative to our 0, 0 point? You'd actually give the x value and the y value. That's what they call absolute coordinate systems. And that's what happens usually when you program. Usually you'll program it in G90, so every one of your values is going to be back to some known 0, 0 point or your origin point. Yeah, Michael?
So then if you wanted to move it, you wouldn't calculate it based on its last point. You calculate it
Based on its initial point, yeah. How far is it away from its initial point? Exactly. So there are just two different modes, and depending on what you're trying to do. So they, like I said, they show here as G90 is your absolute coordinate. Technically, I don't remember they talk about in this, but G91 is another way to set up your program, and that would be what they call incremental. And that's what we're talking about if you wanted to take your numbers relative to the previous point. And that would be incremental. You're incrementally moving based on that. Yeah, Michael.
Which one would you say is better?
I like absolute better. Absolute is usually what I would always program in. Incremental is nice for certain things. If you like for your initials, it could very well be easier to do incremental, depending on because when you guys are programming, a lot of you guys would say, move my robot this distance, right? Well, that distance is an incremental move, right? It's taking it from that last point and moving it, say, I don't know, 800 millimeters or wherever it was in VexVR, right? So a lot of you guys, when you're doing your VexVR stuff, it was moving it incrementally because it was taking it from that last point and just moving it a certain distance. So that's the way to think of incremental. But if we based it off of that middle point where it started a vehicle, then you would have had to know where you wanted to go relative to that middle of the page, and that would have been absolute. So again, when you guys did VexVR, the best way to think of it is that was incremental moves, and then absolute moves is going to be just based on your initial point. All right, so I got into that a little longer than I wanted to, but it's honestly pretty useful information when we get to this, so I'm glad that you guys have some questions about it. So G01, there's usually two prep codes here for G01 and G00. So like I said, the other one is G00. So this one is called what you call a rapid move. G00 would be used usually when you are trying to save time because when you use a G00, it's basically moving the machine as fast as humanly possible. So it's usually its max speed to get from point A to point B. So whether it be you trying to go back to the home position or anything like that, or just trying to move to the next position for your cut position, you would use a G00. A G01 is what they call, they say SL, straight line interpolation, but the easy way to call it is the feed move. So you guys remember when you guys are calculating the IPM, right? So those inches per minute, that's when you would use this feed move. So it's actually you setting a particular cut rate or a cut speed that you want to use. And you would use this G01 to tell it, hey, I want to move at a certain speed. So as we get over here, you'll see you have to call out a feed right here. And that's going to happen when you call out a G01. But if you call out a G00, you don't need an F in your lines of code because it's going to go to the max speed. And then right here, after that, you'll notice that it has the X coordinate, the Y coordinate, and a Z coordinate. So just like we were talking about before with this here, if this was our origin or our 0, 0 point, then it's saying we're going to move X 0.5. So just say that this is 0.5 here. Y 0.5. So that means that we move from here to here. That would be the move that's making. And it's only a two-dimensional move because there is no Z coordinate, right? So if you're only moving in X and Y, or if you're only moving in X and Z, if you're moving in two of the three, it's just going to be a 2D move. So when you do more complex machining, like an airfoil of a, yeah, Michael.
So why would you not want to go use rapid?
So in this case, say that this material, you're actually cutting this line, right? So we're trying to go from here to here, and we're trying to cut something. That's when you want to use a rapid move, because a rapid move you can't actually control how fast it's going. Right, it's just going to go as fast as it can. And normally you don't cut at the full speed. You have to use your calculations or some kind of calculator, or you would use a recommendation from a tool rep, and they would tell you how fast you need to cut depending on your material, like those calculations we did yesterday. So that's when you would use a feed move, or a G01 is when you're actually cutting something. It doesn't mean you can't set your feed rate to be a lot faster. It could be as fast as you calculate or as fast as you think you can cut something. But G00s are usually used just to move from one point to another when you're not trying to cut anything. That's a good question. All right. So, I guess switch back to the mouse. There we go. All right. So again, there's more terminology here. So we already talked about the N numbers, or that N block. The N block is just a way for you to tell us what line of code this is. So whether you say N1, 2, 3, 4, N10, 20, 30, 40, it's up to you. In our industry, we usually started with N100 and stuff like that. We started with a higher number because that way, if you decided later on that you need to add lines of code in between, you had those chunks in between where you could go N101, N102, and then you have N200. So it's an easier way to separate all of your stuff. Again, G90, that's just absolute coordinates. G01, I'm actually not sure why they're going through this again, but G01 is just your feed rate, and then you have your XYZ, which is your positions, and your F is your feed rate. So, yeah, I think basically they're saying that anything in purple or that blue color is something that you can define. It's something that you can actually change. So those N values, the G01s, you can change those. But the G90 is something that you can't change what it does. The G90 is always going to be incremental or absolute, and G91 is going to be incremental. So as far as terminology goes, each one of these statements, or each one of these little chunks here, so this chunk, that chunk, this chunk, this is what they would call a single block. A line of code is obviously the whole thing, and then a block is each of those things that I separated there. So when I say a block of code, I could just be talking about the G90. Yeah, Michael.
So if you called out the G90, you couldn't change it throughout the rest of your code.
You can. So if you start in absolute, the next your next line was N01, right? And you could say G91. If you wanted to change it to incremental there, you can. You just have to put in your line of code. It might just get a little confusing, but you can do that. So then I can say G91, G01, right? Because that is going to be your feed move. And then I could say I'm going to move 2 inches from that point. So in X. So instead of it being X2 relative to our initial point, we're going to be at X2.5 because we moved an additional 2 inches. So you can move from incremental to absolute, or absolute to incremental, depending on what you're trying to do. But a lot of times, especially if we're using a software to program, you're probably going to stay in one or the other.
So you can move from absolute to what?
Incremental.
Okay.
Yeah, or incremental absolute. You just have to call it out in your lines of code. So like I said, right now this was an absolute, so it's going to be relative to your starting point all the time. But if you wanted to say, okay, now I want to move 5 inches relative to my last point that I programmed, you can do that, but you have to say G91 instead of G90. And you don't need this in every single block of code. So say the next block, and I think they talk about this coming up soon. Say I say N01, G01, X 1.0, Y 0.5, Z0, F1. So that was our next blocky code, okay? So my next line is saying that G01, I'm going to stay in our feed move, and we're still moving at 1 inch per minute. But then I wanted to move it to X 1.0. So even though I didn't call that G90, it remembers that I was in absolute already. So you don't have to call out redundant things like that. Technically speaking, I didn't even need to call out the Y 1.5 or the Z0 again. I could have gotten rid of these, and our program would have been fine. I could have just had N1, G01, X 1.0, and then feed rate, and it would move an additional half of an inch to the right. So there are going to be things where you're coding in this particular thing where it's okay to have redundant stuff like that, but as you get more advanced or if you got into the manufacturing industry, having more lines of code like that the computer has to read can sometimes slow it down because your code for making an aerospace part, an airplane part, anything like that, could be thousands of lines. So obviously anywhere you can save some text that the computer actually has to read and process, the better off you'll be because then the computer won't just sit there and try to crunch numbers and do whatever it needs to do before it actually moves. That was a good question, guys. All right. There we go. So here is a list of their G codes, okay? So these are some pretty commonly used G codes, and we just talked about a decent amount of them. So like I said, G90 and G91 are going to be kind of grouped together. You're going to use one or the other. But those are going to be your coordinate systems, okay? G0 and G01 are going to be grouped together because you can usually only use one or the other. So G00 is going to be your non-cutting moves. Like we said, you're going to rapidly move from one point to another, usually trying to save time. And then G01 is going to be what they call straight line interpolation, or like I said, a feed move. It's where you're going to actually do your cutting. Then if you're trying to make circles, they have these G codes right here. So G02 is to make a circle in the clockwise direction, and G03 is to make a circle in the counterclockwise direction. So depending on what you're doing with your initials later, you may need to use a G02 or G03 to make a half circle or make a full circle.
You make a diagonal.
You make a diagonal just by figuring out the XY coordinate from it. It'll make a diagonal based on that. Yeah, because if you want to just do just an X move and then a Y move, so after you would just say only X and you keep the Y the same. So anytime you move, say, I'll draw it, it'll make more sense. All right, so anytime, say we're trying to move from 0, 0 here again, and we're trying to move up here, and I don't know, I guess we'll say it's 4, 4 again. Okay, so if you want to move a diagonal, go from 0, 0 to 4, 4. All you would do is say X 4.0, Y 4.0, and that would automatically make it a diagonal move and have both of them. If we started at X0, Y0. But if you wanted to move, say, to the right first, and then move up, then you would just have your code be like X0, Y0, and you'd have X4, Y0, where you don't even need the Y number, and then X4, Y4. So that kind of looks more like an incremental move, right? Because you are kind of forcing it to do incremental, even though you might be an absolute. But that's basically, depending on what your last position is, it's always going to try to take the shortest route from point A to point B, from your first point to your second point. So in that case, it would be a diagonal line, right? Rather than trying to move right and then up. And then these last ones are kind of things I don't necessarily think we're going to use very often, but so there's this thing called a G04. A G04 is called a dwell or a wait. So remember when you guys were programming in VexVR, there was times when you guys would put a wait in there so that way the motors could actually kick on, right? Or you gave it time to actually see a sensor. The same concept can kind of be applied here. Sometimes in the code, there's this thing what they call look ahead. And with look ahead, your machine is trying to see what are the lines of code ahead of it. But if it's doing that and trying to kind of keep up with the speed of the machining, it might actually skip some of your lines of code. So if you notice anything like that, you usually would add a dwell or a wait which would cause your machine to pause for a little bit before it continues on with its programming. And then G05 is basically a hard pause. It's going to wait for you or for an operator to actually go to the machine. It's going to pause and sit there until somebody actually intervenes and hits the start button again or something like that. So those are some of the initial prep codes or the prep commands for G codes. Everybody got that? And again, guys, hopefully this video actually works well, but we'll see. All right, so now we're going to talk about those R commands. We were just saying that there is a G01 if you're moving in a clockwise rotation, and there's a G02 if you're moving in a clockwise direction, and G03 if you're going to move in a counterclockwise direction. So we have two situations here. We are going to try to make a arc with I and J components. So don't let I and J confuse you too much. Basically, I is going to be the distance, and let me get back to my drawing here. So I, right? We have this I right here. I is the same thing as kind of your X coordinate, but it's relative to a circle or an arc. I'm trying to think of what you guys call it in math. Polar coordinates, is that right? Anybody remember? Anybody know polar coordinates? Anyway, so when you see here that it says I is 1, you can think of this as basically saying in the X direction, it is 1 inch to your, or 1 whatever unit of measurement you're using, but it is 1 inch in this case, as well say, to the point that you're ending on. And then J is the same as Y. So if we were to write anything, you could say I, you can think of I as X, J is Y, and then I don't think we'll ever really be using K, but K would be Z. So you'd have I, J, and K. I guess the main reason why you would ever use a K is if you had more axes of rotation on your machine where you could actually produce an arc on like the side of a part. But since we're really going to be cutting only X, Y direction, you should never really need to worry about this K or Z. So I'm going to clear that. But what we have here, guys, is, I and J are the center point of your coordinates. So in this example, you have N0, which is your first line, right? And setting it to your absolute coordinate system, so G90. And then, I'll go over here just so I can talk a little bit. So then you have this line right here where you do N5, G01, right? So G01 is our feed move. And we're going to move to point X1, Y2. So we are moving from our 0, point for our start point to X1, Y2. All right. So if we look at this thing, basically we're starting here and we're moving to this point right there. That is what that first line of code is doing. It's telling you we're going to move to this start position of where we want to make this arc or the circle. So then the next line, right, is we have a G02. So that is a clockwise arc or circle. So G02 is going to go clockwise, which makes sense because we're going from this green point to this blue point. We're going clockwise. All right. So then the next thing that you guys would put is where is your end point. That's what's shown in this purple here. So this purple is going to be, or I guess that's technically blue, but this is going to be your end point. So just like when you guys are drawing stuff in Otis, Inventor, or whatever, there's multiple ways to make an arc, right? In this case, you made an arc using your start point, your end point, and then you tell it where does the middle need to be. And that's how it defines kind of how big your radius is. So that's where this I and J come into place right afterwards. So you'll see right here, you have I1 and J1. So I1 is going to be your center point in the X direction relative, and your J is going to be your center point to the Y. So again, if I was saying I is 1, that means from my end point here to our center point is going to be a distance of 1. And then the same thing, if J is 1, from here to our center point is going to be 1. It'd be nice if I could write. I guess the better way to explain it, guys, would be this way to this way, right? So our I is 1 and our J is 1 relative to that 0, 0 point. So that is the way you guys could do an arc if you were doing it relative to your absolute coordinate system. So then you'll see that the other example below is going to be talking about your relative coordinate systems, right? So that's like your incremental moves that you guys are doing. So G91, they call the relative or incremental coordinate system. So the first move is going to be the same because whether we're doing absolute or whether we're doing incremental, start from here, you're moving x over 1, and then we're moving y up 2. So that's what that thing is saying. It's not actually going to move over to that right first and then y second. It's just going to do a diagonal line there. But I was just trying to make a point that it's going to move x1, y2, and that's how we end up at that green point. So then, if we do the same line of code, you'll notice that the I and J's are just going to change. So in this case, it's going to be N10, G2. So you're going to do that clockwise rotation again. And then you're going to be at x1, y negative 1. Okay? So this changed. Oh, it did not change colors. This changed though this time, right? Because if we're at this point and we want to get down here at the blue point, then we have to go to the x direction plus 1x. And then we're actually going down in y, minus 1 in the y-axis. That's why our coordinate would then be x1, y minus 1 relative to our last point. So the last thing that we'd have to do then is figure out our i's and our j's. So our i's and our j's relative from our start point there, right, is going to be 0. So we're not moving any of the I because it's in the same point here. So x or I is going to be equal to 0. And then in order to get our center point there, we're going to go down negative 1 in the j. So like I said, guys, I know it's kind of a little complicated, but once you guys do it for the first couple times, you're going to get a hang of it. But most of the time, I prefer absolute. I've told you guys that before. I like to program from absolute. But sometimes there's reasons why it might make more sense or it might be easier for you to do relative. One way isn't necessarily better than the other way all the time, but most of the time people try to just program in absolute because then you don't have to necessarily know where your last point is. You know that your reference point is always going to be 0, 0, 0. All right. So that was one way to do it with I's and J's. The other way that you can do it is actually with R's, and I feel like R's is going to be a lot more easy. It'll make more sense to you guys at least. So here again, they have two examples. They have the example of your absolute coordinates, and you have your example of your relative coordinates. So we're going to make an arc with radius R, and the code is going to be shown there. So you'll see for the first example here, up at the absolute coordinates, you have your N0, G90. So we're telling it that we are going to program in our absolute coordinates. So everything's going to be relative to this 0, 0 point again. All right. So then you have a feed move, that G1, and you're going to move to the point X1, Y2. So you're going to move from here up to that green point. So then the next thing you're going to do is just say N10, G2. And then you're going to say what your endpoint is relative to your absolute coordinate system. So, yes, yeah. You can go to the negative. You can go to the negative side. You can go to, it just all depends, Seth, on where your 0, 0 point is. Because even though I'm saying 0, 0, technically speaking, let's pretend we're milling or trying to create this box, right? I could set my 0, 0 here, which would kind of makes sense, I think, as far as the Cartesian plane works, right? But technically, say there's a hole in the middle of this box. Well, our 0, 0 point could also be that hole, center of that hole. So it really can be negative x, it could be negative y, it could be positive x, or it could be positive y. It all depends on what you say your start point is, and that is going to be the power that you guys have as the programmer when you are trying to produce anything. So, as you see though, this one's a little easier to do because you would just say, based on your start point and end point, what is the radius that you want it to make? So instead of having your i's and your j's, which makes it a little more complicated, you say that you know that your radius is going to be 1 from here to here. That radius is going to be 1, which also tells you that it's where its center point is. As far as the relative coordinates go, honestly, it almost looks exactly the same, right? You just have your relative coordinate being called out, so your G91 or your incremental. Then you have your feed rate being called out, and you're moving to position x1, y2. And then you have your end point being called out relative to this point. So again, because relative to this point, we're moving x is +1 and y is -1. That's why this code would say x1, y -1. And then you just call out the radius again. You want your radius to be 1 inch or 1 centimeter, wherever your unit might be.
So when you add an R into this coding, it'll make the code.
It'll make it work as long as you have a G02 or G03. Yeah. So the key is to always make sure that you're telling it to be in the right mode, right, Preston? So in this case, if we had a G01, which is just your feed move, G01s are almost always going to be in a like straight lines. All right. So here's some other G codes, which we more than likely will not use too much other than the first two. So depending on what you're trying to program, you can actually designate if you want a G20 or a G21. G20 is going to be inches, and a G21 is obviously going to be millimeters. I don't think most of you guys want to work in millimeters, but then again, some of you guys might like metric better than English units. So then you have what they call a CAN cycle. So these will always kind of be used in the group as well, which is why they're grouped together very close in numbers. G80, G81, and G82. So G80 is you're going to cancel your CAN cycle. So you're going to ask, well, Mr. Lee, what is a CAN cycle? CAN cycle is basically like if you know where your start point is of, say, you want to make a bunch of holes, okay? So you'll see that G81 is a drilling cycle. Let's say you want to make a bunch of holes like this. If you're trying to make a bunch of holes, you can do what they call a CAN cycle. A CAN cycle basically is like if you did a pattern on your 3D modeling. So you can tell it, I want to start on this hole right here, and you're just going to move this way and keep milling holes until we get to the end. And then you tell it to move over a distance and do it again, make 3 sets of holes. So it's just basically telling it to make a pattern of holes or a feature. Here's some more miscellaneous codes. So M00 is your pause. M01 is an off stop. So these two kind of stick together. And then these two will stick together. These two will stick together. And then this one is by itself and this one's by itself. Okay. So for M00 or M01, there's 2 ways for you guys to kind of pause your programs. One is actually a hard pause. And what that means is no matter when it sees that M00 in your program, it is going to pause your program. The other one is called an optional stop. And the reason why it's called an optional stop is because usually on your CNC machine or your machine, there's going to be a mode where you can actually say, it says turn off op stops. Basically, you can toggle it to where you're testing your program. That's when you might want an optional stop. But when you're actually running for production, you don't ever really want to stop in that optional stop. So that's the reason why they have those. M2 is end of program. M30 is end of program and reset. So usually this is what you would have down there at the very end of your program, once you are done with machining it and you want it to go all the way back to the beginning of your program so that you can run the next part and it's ready for that. So a lot of times M30 is what we would use at the end of a program. M2, like I said, the same thing. It tells it it's the end of the program, but it's just not going to reset it. It's not going to go back to the top of your program. M3 is spindle on, M5 is spindle off. So these codes will probably be used quite a bit. M6, like I said, we don't have a tool changer. That's good to know. And then M8, M9, M10, and M11. So M8 is on, M10 is on to turn on kind of these accessory items. That could be whether it be like coolant, which is what you use to flush away your chips when you're machining metal, or whether it be some kind of accessory where it might clamp or unclamp your vise. There's ways to kind of use these M codes in a specialized custom way. And I don't think I've ever used M47 before, but apparently it's for a marine line. So here's some kind of best practices that they want to talk about, and I know we only have like 4 more minutes, so we'll see how far we get. But what they want you to know is that the same code is not going to always be required or repeated for every block of code. So that's kind of like saying, we don't need G90 on every one of our lines. As soon as you call it at the beginning, it'll stay in absolute mode unless you want to change it and you call G91. Same thing with the X or Y values. If you're going to just move in the Y direction, you don't need the X to be called out again. Sometimes it's good practice to have that just because it's easier to follow the code when you're reading it by yourself, but it's not necessarily a requirement. You should always specify absolute or relative coordinates, right? So absolute, again, is G90, relative is G91, inch was the G20, or metric, which is G21 at the beginning of your program. So usually you have a thing, what they call a start block. Now, a start block is almost like a default program that you start or put at the top of your programs that usually has, are you going to work in absolute? Are you going to work in inch? And you just use that generic block that you made at the beginning of all your programs. You can move a tool change command to move tool to a safe position away from material, and then indicate what spindle speed each time it's turned on. Like I said, I don't even know how many more. So you should always move this machine in a start position, raise the tool out of stock at the end of the program. So that means after you're done cutting, make sure you come up in Z. So that way you're away from the part, and then you can go back to some home position. All right, so we'll stop here after I talk about this very briefly. But this is basically going to be similar to what we're going to do if I can get those CNC machines running. Is we're going to kind of take a block of material, and then we're going to program this stuff by hand to make your initials. We will have simulation softwares, and this is actually going to be the next activity you guys do in class, where you're going to take what you just learned there with all the different G and M codes, and then try to make your own initials. So if you have obviously a first, middle, last name, you're going to do all 3, just good for practice. If you only have a first and a last initial, then either we'll just throw in a random middle letter, or we'll throw in your last or first initial twice. But the whole goal, obviously, guys, is going to be making these letters based on the endpoints. So you can see here on the M, you're going to start at A, go to B, go to C, go to D, and then go to E. So you have these, you have these points to worry about. Starting point at A, B, C, D, E, and then for H, right, you probably have your F, which is your start point for your arc, A, D, or H, which is your end point. And then to make this arc here, you need to know your center point at I. So we'll call up there, guys, and then we'll continue tomorrow. But that's just going to be like what your actual assignment and project's going to be for this portion of the class.